Hi my dear students, the second video is related to the first video, L'Hopital's rule, but here we're gonna take some more examples about L'Hopital's rule. The first example here, find the limit as x approaches negative pi over 2 of tan x minus secant x. Okay, direct substitution here. It will be tan negative pi over 2, which is undefined, and because we have a vertical assumption at negative pi over 2 minus secant, which is 1 over cosine and 1 over cosine 170, which is 0 over 0 here. So this one is undefined, it will be 1 over 0. So it's indeterminate form. We can rewrite again here this expression as the limit as x approaches negative pi over 2 of the tan. We know that tan is sine over cosine, sine x over cosine x by using the trigonometric identities. Tan is sine over cosine, and secant is 1 over cosine x, and direct substitution, or write it as the same denominator, and the denominator will be sine x minus 1, and then find the limit as x approaches negative pi over 2. When you substitute here, the answer will be sine negative pi over 2, which is 1 minus, it's already here 1 minus 1, which is 0, over cosine negative pi over 2, which is 0, indeterminate form. In the next slide here, I'm gonna apply my L'Hopital's rule. We will find here the limit as x approaches negative pi over 2 of the derivative of sine x. The derivative of sine x is cosine x. The derivative of 1, which is 0, over the derivative of cosine, which is negative sine x. And then substitute negative pi over 2 cosine negative pi over 2, this all over negative sine negative pi over 2. Cosine negative pi over 2, which is 0, and the negative, then sine negative pi over 2 is 1, and we already have negative, so it's 0 over negative 1, which is 0. This is my answer. My answer is 0 here. Question 2. Find the limit as x approaches 1 from the right side, and this is our objective also, to find the limit from one-sided limit from the right side, from the left side, of x over x minus 1 minus 1 over ln x. The limit here is indeterminate type of infinity minus infinity. We combine the terms here and then use the L'Hopital's rule. And let's here first deal with these two fractions. We will try to write them as one fraction, one single fraction, by multiplying here both of them, x here by ln x and up by ln x, and here by x minus 1 by x minus 1. Then my denominator will be x minus 1 ln x. So the limit as x approaches 1 from the right side, 1 plus of x ln x minus, minus what? Minus x plus 1, right? Multiplying the negative by x, and then negative by negative 1 is positive 1. so it's negative x plus 1. And then substitute here, substituting by something like 1.011 1.001 for x, you're gonna get here 0/0. So when you got here this indeterminate form, and it was first infinity minus infinity, now it's 0/0, so we can apply the L'Hopital's rule. The limit as x approaches positive infinity, the limit as x approaches 1 from the right side of the derivative here is, what's the derivative of the numerator? The derivative of x ln x, yes, what's the derivative of x ln x? We should follow here the product rule, which is the first times the derivative of the second plus the second times the derivative of the first, u prime v plus v prime u. So the derivative of the first, which is 1, so my answer is ln x, then plus the derivative of ln x, which is 1/x times x, gonna be 1. Then the derivative of x here, this one will be, the derivative of this x is 1, and the derivative of 1 is 0. This all over the derivative of the denominator. What's the derivative of the denominator? The derivative of x minus 1 ln x, the same thing here, which is product rule we have in the first term. How to find it? The first, which is x minus 1, times the derivative of the second, 1/x, 1/x. (1/x) is the derivative of ln x, plus the derivative of x minus 1 is 1 times ln x. So this one is the derivative of x minus 1. Let's simplify my fraction here. Here will be 1. Right, 1/x times x is 1 minus 1 will be 0 all. Yani here is 1, this all here is 1, and then minus 1, which is 0. So the numerator will include only ln x, so we have the limit as x approaches 1 from the right side of the numerator will be ln x over the denominator. The denominator here is ln x, this one. We'll write it here first. Okay, then 1/x times the first, 1/x times the first, which is 1, minus 1/x. So we have 1 minus 1/x. Then we can substitute by any value, like 1.001 here. You will get here 0/0. If you took any value like 0, like 1, ln 1 is 0 over ln 1, which is 0, plus 1 minus 1/x. 1/1 is 1. 1 minus 1 is 0, so 0 plus 0, 0. You got indeterminate form again, 0/0. So what we have to do, we should apply again the L'Hopital's rule. The L'Hopital's rule for the second time. The L'Hopital's rule for the second time. Yes, we have here, I'm gonna copy again this final step in the next slide or page, which is the limit as x approaches 1 from the right side of the numerator include ln x, and the denominator is ln x plus 1 minus 1/x, ln x plus 1 minus 1/x, and then apply again the L'Hopital rule. What's the answer? It will be the limit as x approaches 1 from the right side of the derivative of ln x is, again here, what's the derivative of ln x? Is 1/x over the derivative again of the denominator all here. The derivative of the first ln x will be 1/x, and then the derivative of this one is 0. And the derivative of 1 over x, what's the derivative of 1 over x? Yes, it's here, it's x to the power of negative 1. And then what's the derivative here of 1 over x? 1 over x squared, right? Yes, so it's a negative, and then will be positive here, and 1 over x squared. Okay, the derivative of 1 over x is Linux. Okay, no, the derivative here of 1 over x, we said it's 1 over x squared. We can square the denominator here by using the quotient rule, and then the numerator, which is 1 times the derivative of the denominator. The numerator 1 times the derivative of the denominator, which is 1, okay, minus the derivative of the numerator, which is 0 times the numerator, or the denominator, sorry, which is x. The quotient rule, I'm sorry here, but the answer will be 1 over x squared. Okay, yes, 1 over x squared. What's the answer here? When you apply here the substitution, 1 to the 1 from the right side, 1 over 1 point something, which is 1 over 1 over 1.000 something will be 1, plus 1 over 1.000 something to the power of 2, which is also 1. So my final answer is half. My final answer is half. Okay. Next example. What's the limit of let's take here one easy example, and then we stop till here in this video. The last example is here. Yes, this example here, this one. Example number 1. What's the limit as x approaches 0 of e to the power of x minus 1 over sine x? Direct substitution, e to the power of 0, which is 1 minus 1, and this all over sine 0, which is 0. So my final answer here is 0 over 0, which is indeterminate form. So let's apply here my L'Hopital's rule. Differentiate the numerator, and find the derivative of e to the power of x. So here the answer, the limit as x approaches 0 of the derivative of e to the power of x is the same, e to the power of x times 1, or e to the power of x. The derivative of 1 is 0 over the derivative of sine, which is cosine x, and then substitute e to the power of 0, which is 1 over cosine 0. Substitute 0 for x here, cosine 0, which is 1. So my answer is 1. Next example. Find the limit as x approaches infinity of x to the power of negative 1 over e to the power of x. Can we rewrite this expression as the limit as x approaches positive infinity of e to the power of x over x squared? Yes, we can. And then apply the L'Hopital directly, since the e to the power of infinity is it's what? It's infinity over x squared. Infinity to the power of 2, or infinity squared, will be infinity. Infinity over infinity is indeterminate form. So quickly differentiate and apply the L'Hopital's rule quickly to find the limit value, x to the power of infinity, the derivative of e to the power of x again, which is e to the power of x, and this all over